Download this code from codegive.com, link in the description below. OK, let's delve into the world of bcom and mcom using Python code examples. I'll provide a detailed tutorial covering the core concepts, common use cases, and limitations of both, along with code illustrations to make things clearer. What are bcom and mcom? Brief overview. *bcom, Business Component Object Model. bcom is a Microsoft technology that was used to build distributed applications using COM, Component Object Model. While COM is still used in some legacy systems, bcom is largely obsolete and has been superseded by newer technologies like .NET Remoting and WCF. bcom allowed developers to create reusable, independent components that could be deployed across a network, communicating with each other over dcom, distributed COM. *mcom, Mobile Component Object Model. mcom, as a specific and well-defined technology, is not a widely recognized or standardized term. The term mcom may sometimes be used informally to refer to the general idea of using component-based architectures on mobile platforms. However, this isn't really a standard tech. Given that bcom is very legacy, and mcom is more of a general idea, I'll focus on the concepts of component-based architecture and how they can be applied in more modern contexts using Python and related technologies. Component-based architecture, the core idea. The fundamental principle behind component-based architecture is to build software applications from reusable, independent modules called components. Each component encapsulates a specific functionality and exposes well-defined interfaces for interacting with other components. Benefits of component-based architecture. Reusability. Components can be reused across multiple applications, saving development time and effort. Maintainability. Changes to one component have minimal impact on other components, making the application easier to maintain. Scalability. Components can be deployed and scaled independently, allowing the application to handle increasing workloads. Flexibility. Components can be easily replaced or updated, providing greater flexibility in adapting to changing business requirements. Testability. Individual components can be tested independently, improving the overall quality of the application. Modern context, applying component principles with Python. While the original bcom technology is largely deprecated, the principles of component-based architecture remain highly relevant. In the Python ecosystem, we can apply these principles using various techniques and frameworks. Here's an example using Python classes to create reusable components. Explanation. One data repository. This component is responsible for data access. It encapsulates the logic for connecting to a database and retrieving data. The get_data method simulates a database query. 2. Order processor. This component implements the business logic for processing orders. It depends on the data repository component to retrieve order data. The process_order method performs some business rules on the retrieved data. 3. Order service. This component represents a user interface or API endpoint. It exposes methods for creating orders and getting order statuses. It depends on the order processor component to handle the actual order processing. Key concepts illustrated. Dependency injection. The order processor and order service components receive their dependencies, the data repository and order processor instances, respectively, through their constructors. This promotes loose coupling and testability. Loose coupling. Each component is relatively independent of the others. Changes to one component are less likely to affect the other components. Asterisk separation of concerns. Asterisk each component has a specific responsibility. The data repository handles data access, the order processor handles business logic, and the order service handles the user interface or API. Alternative technologies and frameworks for component-based architecture in Python. 1 Flask/Fast API, microservices. You can use these frameworks to build microservices, which are essentially independent, deployable components. Each microservice has its own database and business logic. 2 Celery, task queues. Celery is a distributed task queue that allows you to offload long-running or resource-intensive tasks to separate worker processes. This can improve the responsiveness and scalability of your application. These tasks can be considered components of the overall system. 3 Plugins/extensions, dynamic components. You can design your application to load plugins or extensions at runtime. These plugins can be treated as independent components that extend the functionality of your application. Limitations of component-based architecture. 1 Complexity. Designing and implementing a component-based architecture can be more complex than a monolithic architecture. It requires careful planning and consideration of dependencies and interfaces. 2 Overhead. Communication between components can introduce overhead, especially if the components are distributed across a network. 3 Versioning. Managing component versions and dependencies can be challenging, especially as the application grows and evolves. 4 Discovery. Components need a mechanism to discover each other. This can be achieved through service registries or configuration files. 5 Security. Securing communication between components is important, especially if sensitive data is being exchanged. Limitations of bcom, specifically. Platform dependency. bcom is tightly coupled to the Windows operating system. Complexity. bcom can be complex to set up and configure, especially for distributed applications. Security. bcom has been known to have security vulnerabilities. Lack of modern support. bcom is not actively supported by Microsoft. When to consider component-based architecture. Large and complex applications. When building large and complex applications that require modularity, reusability, and maintainability. Distributed systems. When building distributed systems where components need to be deployed and scaled independently. Evolving requirements. When the application is expected to evolve and adapt to changing business requirements. Team collaboration. When different teams are responsible for developing different parts of the application. In summary. While the original bcom and mcom technologies may be outdated, the underlying principles of component-based architecture remain highly relevant. Modern Python provides a rich set of tools and frameworks for building applications based on these principles. By carefully designing and implementing components, you can create more modular, reusable, maintainable, and scalable applications. Be aware of the limitations and complexities involved in component-based architecture, and choose the appropriate technologies and frameworks based on your specific requirements. Remember to consider the trade-offs between complexity and the benefits of modularity and reusability when making architectural decisions.